Welcome back. Here's problem 9. I'm assuming you've seen problems 7 and 8 from the homework on the YouTube videos to check your work. And here's problem 9. Make sure that you go through videos 7 and 8 and then complete problem 9 completely on your own from scratch and then watch the video, which is this one right here. So pause the video if you haven't done so yet and do problem 9 all on your own after watching videos 7 and 8. All right, welcome back. So really you're just checking work. And so quadratic formula, I'm going to go ahead and speed up on this one and just write the thing down straight. So for us, our A value is 2, our B value is -3, and our C value is -5. And so setting up quadratic formula straight from the get-go would be y equals -b plus or minus square root of the b value squared minus 4 times the a value times the c value, then all over 2 times the a value, which is 2 times a value of 2. So double check your work, make sure these things are correct. The next step is to simplify. We've got x equals double negative is a positive, plus or minus square root of 3 squared would be 9. Over here we have a negative 4 times 2 is -8. And then -8 times -5 will be a positive 40. So we've got plus 40. Then it's all over. 2 times 2 is 4. And a couple more steps will be done. So we've got 3 plus or minus square root of 9 plus 40 adds up to 49, all over 4. 49 simplifies down to 7. So we've got 3 plus or minus 7 all over 4. This guy branches off into 2 possibilities, one for plus and one for minus. Let me change pen colors, plus, minus. If it's plus, we have 3 plus 7, then all divided by 4. If it's minus, we have 3 minus 7 all over 4. In the top case, we'd have 3 plus 7 is 10. Let's do it over here. 10 over 4, which reduces to 5 halves. On the bottom case, we'd have 3 minus 7 is -4, divided by 4 equals -1. So our x-intercepts are at 5 halves, which is written as a mixed number. 2 goes into 5 twice with 1 left over. So 5 halves is the same as 2.5. So up here for our x-intercepts, we have 2.5, 0, and we also have -1, 0. There we go. Let's bust out the eraser and get rid of some of the stuff. All right, next up is the y-intercept. And again, I'm assuming you've seen videos 7 and 8, or for problem 7 and 8, where that explains the shortcut to finding the y-intercept. And if I just apply that technique here, -5 is the y-intercept. Written as a point, it's 0, -5. One step done. Next up is a line of symmetry and vertex. The equation that finds the line of symmetry is x equals -b over 2a. And for us, let's plug in our values. -b value over 2 times an a value. The b value was -3. The a value was 2. And double negative would be +3 over 4. So x equals 3/4 is the line of symmetry, which means the vertex is at 3/4, comma something. And to find out that y value, we're going to plug in the x value. So we've got y equals 2 times an x value squared from here, minus 3 times an x value from here, and then finally -5. And we're going to plug in an x value of 3/4 because that was our line of symmetry, and the vertex always lies on the line of symmetry. That is 4. And then computing farther, we have y equals 2 times 3 squared is 9, 4 squared is 16, so there's that dude. This would be a negative overall since there's a single negative. Make that 3 over 1. 3 times 3 is 9 for the numerator. 1 times 4 is 4 for the denominator. Then minus 5. Alright, next. Instead of 2 times 9 and 1 times 16, which is the usual way to multiply fractions, we're going to reduce. 2 goes into 16 8 times. And so we have 9 over 8 is what's left over at the end. So this is 9 eighths. Let's convert this 4 into eighths first, because to add fractions, you need the same denominator. To turn 4 into 8, you multiply by 2. What you do to the top must do to the bottom. 9 times 2 is 18, and 4 times 2 is 8. For the 5, the same thing applies. To turn this into an eighth, you need to multiply by 8 over 8. 5 times 8 is 40, and 1 times 8 is 8 on the denominator. Add them up. Let's see. 9 minus 18 is negative 9. Then if you subtract 40 from that, we're going to get negative 49. So we have a total of negative 49 eighths. And 8 goes into 49 6 times. 6 times 8 is 48, with 1 left over at 8. This seems very similar to the problem with number 7, to be honest with you. So our y-intercept is at 3/4, comma negative 6 and 1/8. Final step is to graph this stuff. So let me clear out some space and then set up a graph. Remember, for you, please use nice and neat graph paper, or use the graphs on the back of the worksheet. Either one's fine, but don't do what I'm doing, which is just freehanding a graph, because they're not going to look so awesome. You'll see mine. Mine doesn't look all that awesome. Alright, there's an XY axis right there. Right there. Let's see. X-intercepts are at 2.5 comma 0, so 1, 2, 3. 2.5 would be right there. Negative 1 comma 0 would be right there. Y-intercept was at 0, negative 5, so 0, negative 1, 2, 3, 4, negative 5 would be here. The line of symmetry is at x equals 3/4, so go over to about 3/4, which is about here, and draw in the line of symmetry. There we go. The vertex lies right along that line at negative 6 and 1/8. So down 1, 2, 3, 4, 5, 6, and just barely past 6 is 6 and 1/8. There's the vertex. Let's reflect this point across the line of symmetry. It'll have a mirror pair right over here somewhere. And this gives us a very nice looking parabola right about here. And this is hard to draw with my little pen stylus, so I apologize, but there. There's my beautiful old wrinkly parabola. It's a raisin parabola if you were in 5th period. This is my raisin parabola, but it's still a beautiful parabola. Anyway, there you go. There's problem 9. I'm not going to do any more videos, so follow the pattern in problems 7, 8, 9 for the videos, and complete problems 10 and 11 on your own. I'll see you next week. Have a great weekend. Bye.